Hello and welcome to computer class. My name is Dave, and today we're talking about the World Wide Web, or the dub, as people have entitled it. So I want to start out by giving you a definition of what is the Internet. The Internet is a worldwide collection of networks that connects millions of businesses, government agencies, educational institutions, and individuals to all the information that is out there online. It's otherwise known as, and this is a very important definition, a three-word definition, how I would describe it, a library of documents. Okay, if you look at the way HTML is written, basically they're nothing but documents stored on a server, and you're accessing those documents. So basically, the entire internet is nothing but documents. The compound word internet or internal web basically is what the word represents. Um, and I think a better definition, even than a library of documents, could be a network of networks. That's what the internet is. It's, as we talk about this idea of networks, it's a whole bunch of networks connected together to create a network of networks. It's great. So, couple definitions: library of documents, network of networks, to describe how the internet works. How did we get the internet? So here's some just general knowledge that is on the internet that you can find in a textbook called Discovering Computers. The internet has its roots in a networking project started by the Pentagon's Advanced Research Project Agency, an agency of the U.S. Department of Defense. The goal was to build a network that, number one, allowed scientists at different physical locations to share information and work together on military and scientific projects, and number two, could function even if part of the network were disabled or destroyed by disasters such as a nuclear attack. That network was called the Arpanet and became functional in September of 1969, linking scientific and academic researchers all across the United States. So it's really cool. The first purpose was basically so that scientists at different physical locations could share information. That makes sense. And then the internet is so cool because if one part of it goes down, you can just reroute the traffic or the packets, the information down other parts of the internet, and not have to disable the entire network as a whole. So it all works, even if part of it goes down. So who owns the internet? No single person, institution, or government agency owns the internet. Each organization on the internet is responsible only for maintaining its own network. That's the key. Okay? So again, nobody owns it. Really, the ISP or the internet service providers support or keep up the infrastructure of the internet, and then other people have servers that they run that maintain the search engine optimization, and like Google has servers and stuff that maintains and holds data of the internet and different things. And there's people that crawlers and stuff who keep the internet running and all the listings that pop up working. So all that is on the internet, but no single person owns the internet or institution. It's all pieced together. Okay, that's why it's intranet. Interworkings together, internal network. Everyone is working together on the internet. It's basically a massive library of things. All right, how do you connect to the internet? Well, the answer is simple actually. It's a modem. So I have one of these here. You can see it. It's made by Netgear, I think. And not all modems are routers and all routers are modems, but this one happens to do both things. I've already talked about what a router is. This one happens to, as you can see, you can plug this white cable into the back of it, and this will come in from the coaxial cable will come down the road to your house, and it will come in the wall, and it'll plug into the back of this right here. And this produces, it turns the analog signal into a digital signal. So it produces Wi-Fi. And that's what a modem does. Now this also has, again, a wireless capability, so it's also a router. It's 2-in-1. But sometimes people have, multiple things sitting side by side, but this is just a modem and a router in and of itself. So what you do is a cable modem is a device that enables you to hook up your PC to a local cable TV line and receive data. A modem is a device that modulates an analog carrier signal to encode and then decode the digital information. It converts the signals outside your house to signals that can be read by a computer. That's what this device does, and then also puts out a Wi-Fi network that you can connect to and get on the internet. And also it has little hardwire ports on the back right there, if you can see those, that you can plug Ethernet cables into and split the connections if you need to. And people can also hardwire into the internet. And of course, it has a USB port as well. So this is a router and a modem. What connects to your modem? Okay. Well, what connects to this little thing right here, as I just stated? An internet service provider, someone who sends the internet down the wire to your house. An ISP, as they're known, is a business that provides individuals and organizations with access to the internet for a fee or for free, usually for a fee. Let me tell you, they like to charge money. Okay, ISPs often charge a fixed amount for internet connection, offering customers a variety of plans based on a desired speeds, bandwidth, and services. In addition to internet access, ISPs typically include services such as news, weather, finance, travel, data, email, instant messaging, photo communities, and online storage. At times, you'll often see they'll give you an email and stuff like that. Okay, anyway, that's not as important. What is important? What is an ISP? Okay, what is an MSP then, or mobile service provider? Also called a wireless data provider, is an ISP that offers wireless internet access to computers and mobile devices with necessary built-in wireless capability. Stuff like your smartphone needs an MSP. Places like Verizon and AT&T and those companies offer services so that you can hook up your phone and get it online. And you're able to use it with these towers that exist all over the United States. An antenna on or built into a computer or device, wireless modem, or communications device typically sends signals through airwaves to communicate with a mobile service provider. That's how the mobile service provider works. So again, sending it through the airwaves to the tower, and bam, bounce off another tower, all these different towers until it gets the other person who's then texting you back. Okay. That being said, if you're inside of a house and connecting right here to the back of this, you use something called a coaxial cable, and this is what the connection looks like actually. I don't know if you can see that or not, but I have a reel of it here or whatever. And this coaxial cable is the actual wire that connects to your house. Usually, it's a type of transmission line that uses high frequency electrical signals with low losses. And it is used in such applications as telephone trunk lines, broadband internet networking cables, high-speed computer business buses, data buses, carrying cable television signals, which some of you have at your house, and connecting radio transmitters and receivers to their antennas. So this cable has a lot of uses, and it's really cool for getting you online. So we have cable internet, and again, cable internet, you sometimes have to split this so that it can go to all your TVs in your house. And again, one of those splits would come to this router, and they'd be able to decode it to have Wi-Fi. All right. So, and by the way, that's not true of not all. And I may have deceiving when I said this. Not all places get this cable hooked up to them. Sometimes coming down the road, there is fiber internet. I'm going to talk about that in just a second. But so businesses tend to get high-speed internet to them and different services than, like average users at a house. So they need a different type of cable usually. Sometimes it's a fiber cable running down the road and things like that. But this runs directly up to one's personal house usually. Okay. Anyway, there we go. What is a broadband internet service then? And this is just a definition term for the way internet is transmitted to us. Okay, broadband is provided by an ISP or internet service provider, a high-capacity transmission technique using a wide range of frequencies, which enables a large number of data packets to be communicated simultaneously. Again, the key word in there is data packets. That's what the internet does. It's basically data packets traveling down all these wires, going between individuals. When you send a text, it's pulverized down to little bits, each encoded with a specific encoding, and then it is sent, and the pieces are reassembled on the device when they are received. Broadband commonly refers to high-speed internet access that is always on and faster than traditional dial-up access. Okay, so that being said, here is several videos I'll link down in the description about what is broadband from these really interesting fellows who have come up with these videos. To be honest, they're a little bit weird. And then we're going to talk about the 7 types, I believe it is, 7 forms of broadband here. The first is not really used anymore. Okay, and this is just a blast from the past to give you guys knowledge about what exists. It's dial-up internet access. So when I was a kid, to tell you a story, internet was slow. Like you can go make a sandwich before things would load. The little cat loading on the screen there, I think it is an example of how slow things were on the internet. And it used the phone line service to access the internet. So you would dial in to the internet essentially. And the definition of it is there, as you see in front of you. But dial-up internet service has all but gone to the wayside because we don't really use it anymore. It's too slow. Nobody really wants to. We started going to, these type of cables, not the phone line cables. And so that being said, we have cable internet service now. Provides high-speed internet access through the cable television network via the cable modem. And so now we plug these into our coaxial cable, and we get the internet from it. Cable internet service is a type of broadband connection that transmits data over a cable television network, typically faster than DSL and cheaper than fiber optic. A cable internet connection offers a great balance of speed and affordability. That's why it's so popular. Just about everybody gets on the internet using this methodology. Okay, so this is the most popular one, the cable internet service. A third is digital subscribers line, or DSL, provides high-speed internet connections through a telephone network via DSL. Again, more of a form of legacy, how things used to be done. It's still around today, but more how things used to be done in the high-speed world. Okay, and here is replaced with the more high-speed world of today, which is number 4, fiber to the premises, or FTTP, uses fiber optic cable to provide high-speed internet access via a modem. So for businesses, we tend to shoot around things using fiber so that it gets there faster. And I don't have a piece of fiber today to show you. I have one at work I could show you, but it's cool stuff. There's a picture of it on screen. It's not quite that big. It's really thin, tiny wire. This is even like really small. That's not much to hear. A fiber is even like half of this. It's really thin. So, and there's lots of strands in it to get everybody online, business-wise. Number 5, mobile broadband. I already talked about it. Offers high-speed internet connections over a cellular radio network to computers and devices with built-in compatibility technology such as 3G, 4G, 5G, or wireless modem or other communications devices. All right, so that's wireless broadband. And in the United States, there are 2 types of wireless broadband that exist. In the United States, AT&T and T-Mobile are GSM carriers, and I'm going to explain what that means in a second, while Sprint and Verizon are Cdma carriers. Also, swapping phones on a GSM network is easier because GSM compatibility phones use SIM cards. So SIM card is a little card that slots in the back of your phone. In terms of the relevance of 3G and 4G LTE bands and frequencies, the thing to know are that Cdma and GSM only use 3G technology. Now they use 4, if I'm not mistaken. Many Sprint and Verizon phones have SIM cards, but that isn't because of Cdma. The SIM cards are there for Sprint's and Verizon's 4G LTE networks because the LTE standard also uses SIM cards. The phones may also have SIM card slots to support foreign GSM networks such as world phones. Okay, so 2 types of mobile broadband then, if I could talk. Wow. GSM, or Global System for Mobile. It's much easier to swap phones on a global system. That's why you see people have burner phones, right? They pull the SIM card out, crack it in half. You've seen it on the videos, and they throw it away, right? Because these are GSM carriers, and they put the customer information on a removable SIM card, take the card out, put it in a different phone, and the new phone now has your number. What's more, to be considered GSM, a character must accept any GSM-compatible phone. So GSM carriers don't have total control of the phone you're using. You can use any phone you freaking want. It's great. Number 2 is Cdma. They're a little more locked down on it. It stands for Code Division Multiple Access, and that's not the case with Cdma. In the U.S., Cdma carriers use a network-based whitelist to verify their subscribers. That means that you can only switch phones with your carrier's permission, and you have to call up and get it all switched over. And a carrier doesn't have to accept any particular phone on its network. They can be like, nope, we don't accept Galaxies, and suddenly you can't use them. It could, but typically the U.S. carriers choose not to. So a helpful terminology to know with regard to cell phone characters is LTE. What it stands for long-term evolution, and it's a global accepted 4G wireless standard for all U.S. carriers. A few phones support all 4G carriers by combining Cdma, GSM, and LTE, and they are the iPhone 6 and later, the Motorola Moto G4 and later, the Samsung Galaxy S7 and later, the Nexus 6 and later, the Google Pixel phones, and all these work across all 4 networks, just so everybody knows. So more than likely your phone does both and you just don't know it, but it is helpful to know which carriers do which, okay, if anyone's wondering. So to go back to that illustration, it might be better to get GSM depending on if you travel a lot, or CDMA if you're in the United States a lot, just so everybody's clear on that. Okay, if you want to switch phones often, use your phone in Europe or use imported phones, just go with AT&T and T-Mobile. It'll be easier. Or virtual carriers on those networks. Otherwise, pick your carrier based on coverage and call quality in your area and assume you'll probably need a new phone if you switch carriers. So, it's a typical thing. Sometimes you have to switch phones, you switch carriers. I've done it. It's difficult, but it can be done. Back your phone up, type of thing. Number 6, fixed wireless provides high-speed internet connections using a dish-shaped antenna on a building, such as a house or business, to communicate with a tower located via radio signals. So basically, they beam the internet from a tower to a location, to a home antenna that's on the top of the house, and this receives it and then goes to your router, and you have internet in the house. Just pretty neato bandito, if I do say so myself. And that's a way that people get internet. It's known as fixed wireless, like shooting the internet or beaming it to you almost like a laser. Not a laser, but almost like it. Satellite internet service then is the coolest of all, and one day, because of Starlink and Elon Musk, we will have internet up in the atmosphere of the Earth. And we already have it kind of now. People have sat phones and they have different things that they can access from satellites, but it's not to the par where everybody's online yet. So it's getting there. But it provides high-speed internet connections via satellite to satellite dish that communicates with a satellite modem. So you have a dish on top of your house, communicates to satellite, communicates to something else down on the ground, which is pretty cool. It's like the satellite is the middle guy, and it just beams up to it, which is cool. One day we could be online from, that's so cool. Anyway, from the Earth, from outside the Earth, we could have the internet as this crystal ball around the Earth, whatever you may say. Okay, and then number 8, Wi-Fi, of course, is technically wireless broadband, right? Wireless network router connections to a modem. Here we go. Wi-Fi, what is it short for? Wireless fidelity. That's pretty important to know. If you don't know what Wi-Fi stands for at this point, then learn that. Wireless fidelity. Wi-Fi users use radio signals that conform to the 802.11 standards, which were developed by the Institute of Electrical and Electronics Engineers, or IEEE. Computers and devices that have the appropriate Wi-Fi capability can communicate via radio waves and with other Wi-Fi computers and devices. That is so cool. Thank goodness for that. Wireless fidelity. Okay? So how did they come up with the name Wi-Fi? Again, this gets me every time, okay? In 1999, the fledgling wireless industry needed a marketing name for a new product that conformed to the technical specifications called IEEE. Or 802.11, and they're like, man, it's not catchy. IEEE 802.11 didn't have much of a ring to it, and the industry association wanted a catchy name, so they came up with Wi-Fi, which is short for wireless fidelity. So originally it was named IEEE 802.11. Thank goodness they didn't stick with that. Now we got a little logo and everything, whatever. I'm glad they did that. All right, so sharing the internet. How do we share the internet? Well, there's several ways. There's public internet. Something known as a cyber cafe. It's a location that provides computers with internet access, usually for a fee. You can see them at hotels and airports. Most hotspots are open access. Some require you to accept a terms of agreement. Others ask you to obtain a passcode, for example, from a hotel's front desk. And a hotspot is a wireless network that provides internet connections to mobile computers and devices. So maybe you've seen them. You can buy these little boxes um, that you can connect your phone to, or you can turn on your phone. There's a little checkbox in some phones. You turn it on, and you have Hotspot up and going, and everybody can connect to it. That's known as tethering, I think is the term. Personal internet connection, there it is, tethering, right? You just go in and say, I have a picture right there. Sweet. You can go in and you just turn it on and you set your passcode, and then transforms a smartphone or internet capable tablet into a portable communications device that shares its internet connectivity with other computers and devices. And then a mobile hotspot is a device that serves as a link between the Wi-Fi devices and cellular data network. And so you can get mobile hotspot, tethering, Cyber Cafe. A hotspot is where, I guess this hotspot would be considered, um, like in an area like an airport or something like that, where you want to get internet, maybe a Starbucks or something. Cyber Cafe is kind of a Starbucks too, so it's a bit confusing because they're all like basically similar. We have public internet and we have personal internet. These are the two personal ones. These are the two public ones. Yeah, you get the idea. All right. Internet data usage. Bandwidth represents the amount of data that travels over a network. A higher bandwidth means that more data transmits. Data sizes typically are stated in terms of megabytes and gigabytes. Okay, but mainly the lower end of things. So a bit is short for binary digit, the smallest unit of information on a machine. Okay, something either a 0 or a 1. The term was first used in 1994 or 1948 by John Tukey, I think it is, a leading statistician and advisor to 5 presidents. A single bit can hold only one of two values, a 0 or 1, meaning meaningful information is attained by combining consecutive bits into larger units. Your internet usage is measured in bits, so it's measured at the lowest level, 0 and a 1. Okay? That being said, byte, a binary term for a unit of storage capable of holding a single character, like a number or a letter, is 8 bits. So this is how you kind of do the value system and do the math for it to figure out how much you're using for your internet. And internet services are still down in, the bits, as we stated. All right, so internet usage, here we go. We got kilobytes. You can utilize megabytes, gigabytes, terabytes, petabytes if we're storing stuff on a device. But as I said, where's internet usage? Bits. Look how far behind the internet is from storage. It's not as far along as we think. We do not have crazy networks up and going yet that can transfer gigabytes of data. It's just not possible. Not yet. It takes, hours to transfer that much information from one location to another. We're still doing it in bits, a 0 and a 1, and sometimes in bytes, 8 bits at a time. And certain days we're up to a kilobyte, but we're definitely not up to these other levels where a petabyte or a terabyte. Look at that, 1 trillion bytes. No, we're not at that level yet. But maybe one day the internet in your future will be there. We'll just be able to drop a file, boom, and it'll be on another device immediately. That'd be so cool. But look at the measurements here. It's insane. So look how many megabytes there are. 1 million bytes, 1 billion bytes, 1 trillion bytes, quadrillion bytes is a petabyte. It's insane. Maybe one day. The internet, by the way, is at the petabyte level, if I'm not mistaken. And then they already are working on the exabyte, which is 1 quintillion bytes. 5 exabytes can contain all the words that have ever been spoken by human beings. just fathom that for a second. All right, just fathom that. Exabyte, and then the zettabyte is 1 sextillion. Each one of these is 1,000th of the other. So just so everybody's clear on the math that's going on here, this is how much storage we will have in the future. We will probably make it into the exabytes. Who knows? But right now we are stuck at the storage level, on the petabyte level, and at the transfer of data level, we are stuck on the bit level. Isn't that crazy? The bit and the byte level. I mean, that's just insane. So, hey, maybe in your lifetime, develop the technology to get stuff to transfer a little bit faster, because the internet needs to catch up to the storage world, because it's way ahead. And anyway, that is the end of this lesson. Hopefully, learn something about the internet and the the World Wide Web. And I will see you in the next video.